Assalamu alaikum. My name is Fakisha and my group members' name are Kashif Anwar and Shiva Boss. Today I'm going to present my DLE lab project that is a line follower. So in my lab project I am using 4 input and from 4 analog IR sensors, and I'm going to run 2 motors, that are left motor and a right motor. From those input I have to design a combination logic circuit for its implementation. So here I have made a truth table for these are the 4 inputs. That is my left sensor, these are to my center sensor, and this is my right sensor input. So this center, I have made a logic for these 2 center sensors, and that they would be on the line. So they have to detect the black line, and these 2 left and right sensor have to detect the white surface of the of any base that on which our robot will be moving. So these motor have to be controlled by these sensors. So this is a truth table. So there are 16 logics made by these 4 sensors. So the first what is 0 and 1 for our sensors? So for 0, that is a black line, that is our IR sensor, is when it does not get back the reflected IR infrared rays, and so as the black absorbs the infrared rays, so it doesn't get back, so our sensor gets a 0 input. Whereas as white surface reflects the infrared rays, so our sensor gets the input, that is 1. So it detects a white as it's off the line and not on the line. Sensor is not on the line, and online, that is the sensor is on the line, is the black, that is a 0 input. So so this is the case when all our this is the case when all the inputs are zeros, that is all the 4 sensors are detecting black line. It is the only case when our motor should stop, that is the T junction, when our motors should stop and our rover or robot should stop. And on others, all the others logics, some of the motor should work or all the motor should work. So in the first case, I will show you how the system is working by discussing a few of the cases. So in this first case, when it's 1, so that is the right sensor is 1, it shows that it is off the line, the white surface, and these all other are 0, and its SL should not detect 0, as it should be off the line, which is this is our main case, that is 1 0 0. This is our ideal case, that is this left and right sensor should be on the white surface, and this center 2 sensor should be on the line, so then both the motor should work. So in this second case, when this left sensor was not detecting that it was not on the off the line, it was on the line, so our right motor should work. It should work and bring this left sensor on the line as it is moving away from the surface or the line. So in a similar way, over here, when left and center both are detecting 1, but here these centers should be 0. So it means it is all off the line from the center. So our left motor should work to bring them on the line in order to move them on the other direction, and the second motor, the right motor, should be 0. So according to this truth table, we have designed a K-map for the left motor and the right motor, and from those, after solving the K-map, we have came up with these equations for the formula. So from this formula, we have made the combination circuit. This is a combination circuit diagram for this is for the left motor and this is for the right motor. So on implementing this combination logic circuit, we have designed this simulation in the Proteus. So over here this is our battery system. So this is our battery. It is a 18650. That is, we will using 2 cells of that to make a battery. And here is a voltage regulator that will convert that voltage into 5 volts. That is for the ICs, so that our ICs might not burn off. And here battery connection I have made for the PCB layout, because there was no any PCB layout for this battery connection. So this I have made this battery, and I have made this battery connection for the PCB layout A7805. And here I have made circuit, combination logic circuit. So here I have used the bubbles so that my complexity might reduce, and I have easy understanding of which input is going for the which output. So by doing that, so here I have seal connectors. These seal connectors are helping me in the PCB. I will show you later. And here are my motors. This is left motor and right motor. Here is our truth table, and here is the same logic that I have discussed. And here are 4 IR sensors. So we will be implementing this. I will run the simulation. So here you can see that when I have run my main the ideal case, that is when my center will be on the line, center dot both the IR sensor, the SC1 and SC2 are on the line. My SL left sensor and the SR right sensor are off the line. So my motors are running. You can see my motors are running. They are running slowly. I don't know why the speed is slow, but they are running. That might be of the voltage, or my system is slow. They are moving. So in similar way, if I have to take a turn, that is, I want to move my right motor, that is 0001, that is, my right center should be 1 and the left should be 0. So my right motor should be moving and left should be 0. So here this motor should be moving. You can see it's moving, but it's 0 here, like that. So if I want to move ML, that is my left motor, I have to make all the others 1 and SR 0. SR should be 0 and this all should be 1. So in this case, wait a minute, 1110. So in this case, now my MR motor has stopped, and my left motor is running. You can see. And this ML and MR connection are only for PCB layout, because motor has no PCB layout. So if I move on to the PCB section, here I have designed PCB. So we have designed a complete PCB with the IR sensor connections, and not only for the combination logic circuit. We wanted to make a PCB that should be in itself should be a robot base, and in itself should be the connection for everything. So it's a whole robot base and a PCB as well. So over here, if I see here, I have the 3 ICs and 3 gates, the 7404 ICs, 7408 IC and 4075 IC, and this is the voltage regulator 7805. Here are 2 motor connection, ML and MR, and I have wired it. I wanted to make it more on the bottom copper, but some other connections have gone on the top layer, which we will be implementing by using connector wires. And this is the battery connection, and this back one is the wheel, the third wheel of the brand. So this is a full scaled PCB that is 17 centimeter long and 9 centimeter wide. So if I go to 3D visualizer, here you can see this is the PCB layout. This our robot should be, and robot should be look like this when we will implement practically. So here is the heat sink with the 705. Here are 3 ICs with the silk connectors, battery connection, battery holder, and there are 2 motors. Okay, the third wheel. These are IR sensors. So this is the complete packet, complete robot. So I think this was it for the simulation and our work that we have done up till now. So our next work will be implementation of this all into a real PCB and a real robot. So this is our breadboard implementation of our circuit. So we have over here batteries, voltage regulator, LEDs, and force sensor and ICs all connected through wires on the breadboard. So this is the rightmost sensor of our project, and this is the leftmost sensor. These are center 2 sensors which will be on the line. The rightmost will be off the line, and the leftmost will be also off the line. So this is a voltage regulator. The voltage regulator regulates the voltage, input voltage to 5 volts, and this 5 volt is then given to the ICs and the sensors. So we have used 3 ICs over here of 3 gates, which are AND gate, OR gate, and NOT gate, 7404, 7408, and 4075 respectively. So our batteries of 9 volts is give 7 to 9 volts, and this regulator regulates to 5 volts, and then this 5 volts is given to ICs and the RF sensor, as they both operate on the 5 volts. So in order to decrease the current and so that our ICs do not blow up, we have used capacitors. So these are 2 LEDs which will indicate the motors. This is the right LED indicating right motor, and second one is the left LED indicating left motor. We have not used the motor driver and the motors in this implementation, only to demonstrate it that how these sensors are working in real world, so on breadboard. So in this implementation we have done this with the sensors and the ICs. So this we will demonstrate you how these motors, LEDs, which are indicated by LEDs, work with these sensors. So you can see if these both left and right sensors are off the line, the LED should be running because these 2 sensors which are in the middle are on the black surface or on the, so there is no difference. The motor should be working. But if the 2 of the one side, 2 sensors of the one sides are blocked or off the line, that motor should be off, and the other motor should work to bring it to bring the center 2 sensors on the line. So if the right ones are off, the left motor should bring it, and if the leftmost are off, the right motor should bring it. So this work oppositely. So it doesn't affect if one of the sensor is off, but if 2 to 3 sensors are off the line, the they work to bring the center two sensors on the line. So this was the breadboard implementation of our circuit. If I block all the sensors, you see the robot stops. So here we have PCB development process. We have taken the print of the bottom copper onto the butter paper or sticky paper, and we have pressed it on the copper plate. So this is the print we got on pressing on the PCB board. So after doing that, we have done the etching process. We have made the etching solution. We have made the FeCl3 and water solution, and then dip our PCB board into it and give it to 10 to 20 minutes for the process of etching. So it all depends on the quantity of FeCl3 that we put in the water. So after this etching process, when all etching was done, we have washed the surface out and removed this black coating out so that we got the copper. So this is after removing the black print. This we got the bottom copper, and after that we drill out the holes from the surface and then solder the components onto the PCB board. So this is our robot that is completing a lap on the line, is following line perfectly. So that was it from this video. Thank you very much.